2. All right, this is what we did last time, right? We started talking about ionic compounds, and we talked about how to write the formula for an ionic compound. Assuming that and how do you recognize if you have an ionic compound? That's step 1. How do you know that all 3 of these are ionic compounds? Who said that? Very good.
What was it looking here?
There's a metal and a non-metal, right? And these ones are main group elements, both the metal and the non-metal, right? And so to write the formula, the first thing you do is you write the ion with the charge on it. And then we showed how to do the crossover thing, right? So I'll do this last one down here. Right? So we take this, and we take the 2 and put it down here. We take the 3 and put it there. So the result is Mg3N2. Okay? Everybody remembers that, sort of? Well, it's been a week. Who started on the homework for chapter 6? A little bit? No, a little bit of it? Okay, good. Shouldn't have done it all, right? Because there's still a lot we haven't covered, but we'll finish chapter 6 Wednesday. So that's how you write the formulas, right? So you guys should all be good at that because we did that last week. So now, how do we name these ionic compounds? My biggest thing about students is, we talk about this like day 1. A lot of times when I teach chemistry, I always ask, who's had chemistry before? And I ask, who's happy to be here? And everybody raises their hand, right? And I say, who's terrified of chemistry? And how many people you think raise their hand? Most people raise their hand, right? But you know what? You already know a lot of chemistry. And that's part of teaching, is to get you to realize you know some stuff, and we're just going to try to extend what you already know a little bit, okay? It's not all brand new to you. Do you know how to name any ionic compounds? Well, you know how to name this one, don't you? What is this one? Sodium chloride. And what is sodium chloride?
Salt.
It is a type of salt. It is table salt. It's what we call salt, table salt, okay? Chemists don't say that it's salt, it is a type of salt, because there are literally thousands of salts, okay? Do you see anything in this name that you think might be useful for us going down the road? Well, what's this over here? It's just the name of the element, isn't it? Sodium. That's not hard, is it? Now what about this part over here? This is the non-metal, right? But it's not chlorine anymore, is it? It is now chloride. And last week we talked about the names of these nonmetals and how their names change. The ending of the name changes, right? We even gave the names for lots of those nonmetals, didn't we? Okay? So always, if you get stuck, think back to what you already know. You know a little bit of this, don't you? Okay? So, when naming ionic compounds, name the metal first, and it stays the same. It doesn't change, the name of the element. Then you name the nonmetal, and the nonmetal's name is going to change. The ending of it will change to end in IDE normal. Okay? So 2 words, metal, nonmetal, with a nonmetal ending in IDE. And we're going to practice. So, here's some examples. First one, potassium iodide. Second one, magnesium bromide. Aluminum oxide. Okay? Now, do you see anything in these names that tell you how many of each atom you have, about each ion? Is there anything in there that tells you how many of each ion you have? Not in the name, it doesn't tell you that, does it? But because you already know some stuff, you can figure it out, can't you? You should be able to. You're going to be able to. Okay? How's that? We're going to practice it. We're going to work on it today. So, let's work on naming this guy right here. Or Same one up here. What do you think? What's the name of this? Is this, number one, is it an ionic compound?
Yes.
Because this is a metal and this is a non-metal, right? Okay? So what's the name of the metal? Potassium. And what's the name of the non-metal?
Oxide.
It's oxygen, and the name changes to oxide. It is potassium oxide. 2 words, right? Space in the middle. Fair enough? Now, if I told you that you had potassium oxide, could you make that and go backwards to the formula? You should be able to, because think about it. Potassium, where's potassium on the periodic table? It's in the first column, so what's the charge? So this is K plus, isn't it? And what's oxide? O, 2 minus. So from this, if you do the cross, you should get that, right? So you should be able to go from the formula to the name and from the name back to the formula. Okay? And I know a lot of people, that's what I try to explain, you know, most of the students in the 130 are vet tech students, and nothing to do, nothing, I'm not holding anything against the dental hygiene people. But you did dental hygiene, you have the same thing, right? Because here, instead of saying pass the salt, that's like saying, hey, look at that tooth. You don't know which tooth you want to look at, do you? Because there's, how many teeth are 32? Hey, look at that. I'm good. I feel good. I have my wisdom teeth out, so I only got 28. So. But your teeth are numbered, aren't they? And each one of them has a number, and they even have names too, don't they? Yeah, see? Yeah, so without having that terminology there, you can't really discuss it too well, can you? Or if you're going to be vet tech, it's like having a whole room full of dogs and every one of them's a different breed. You say, hand me that dog. Do you want the Jack Russell Terrier? Do you want the Basenji? Do you want the Alaskan Malamute? Do you want the Pug? Do you want the Heinz 57 dog? Which one do you want? Right? You gotta be more specific with your terminology. And this is chemistry, okay? This is our terminology. It's very specific. When you say potassium oxide, it means this right here. 2 potassiums, 1 oxygen in an ionic compound like this, okay? That's why we spend a lot of time on terminology in here. So, can you guys name these? Take a minute to name these and then we'll talk about them. So what's the first one?
Calcium oxide.
Calcium oxide. The next one's still going to be oxide, isn't it?
Yes.
But in this case it's
Aluminum.
aluminium oxide. You never heard it called aluminium? It's the British pronunciation. They put an extra I in it. I took organic chemistry from a British guy. He said aluminium for a semester. I never knew what he was talking about. It was terrible. It's aluminum, right? That's what we call it. Most of the world calls it aluminium. They have an extra I in it. And this one? Magnesium
Chloride.
chloride. Thank you. I want to change slides over. All right. So, fill out this chart. So write the formula and the name in each box. So the idea is, I'll do the first one. So if I mix this with this, I get NaBr. Is that right? Is that the right formula? Plus 1 and minus 1, so yes, it is. Okay. And the name for this is sodium bromide. So complete the chart. Are we ready? So what's the next one right here?
Sodium sulfide.
What's the formula? Na2,
2 S.
because it takes two of these to equal one of these, right? I have to have two positives to equal the two negatives. So it is sodium sulfide. Okay. Now for this one, this is -3, so it takes 3 sodiums, right? Na3N. Still sodium. 9 tried. Okay. This one. One aluminum has 3 plus. So how many bromines do I need?
3.
So it's ALDR3. Really? Bromide. Now this is probably the hardest one to get the formula, right? If you cross the charges over, it becomes Al2S3. Aluminum sulfide. Okay, I'm not gonna write. And this last one, 3 minus and 3 plus, it is just ALN. And it is aluminum nitride. Okay. So, those are the ionic compounds when you have a main group metal and a non-metal. It's all a non-metal main group. Now, look at this. Look at these things down here. These are elements that have variable charge. I don't have a periodic table. Let me borrow yours first. Let's look at the periodic table. The main group metals are only these 2 groups right here plus aluminum. Okay? Everybody sees that? So groups 1 and 2 plus aluminum. But look at all the other metals that we have on the periodic table. We have all this stuff down in here. Goes way down under here, includes things like lead, and then these 2 rows down here. All these are also metals. Why are those not part of the main group? Because they have variable charges. The main group elements have fixed charges, right? I told you guys last week, write these on your periodic table. Group 1 is always 1 plus. Group 2 is always 2 plus. Aluminum is always 3 plus. Now we're going to talk about things that aren't always a certain charge. All those transition metals and all the things at the bottom have variable charges. Exceptions, write these on your periodic table. Zinc and cadmium are always 2 plus. Zinc and cadmium are always 2 plus. Silver is always 1 plus. Okay? So, every other transition metal has variable charge, and when you name an ionic compound, you must use a Roman numeral to tell what the charge is on that metal atom. Okay, we're going to do some examples. Look up here, they have some combos. Don't look at, in the book it has a chart, and that chart's not complete.